we're going to go ahead and take a look at problems 8.1.9 and 8.1.13. And so in chapter 8, we take a look at a concept called sampling distribution. So on this problem number 3, what we're given some information is we're given the information about the population. The population has a mean of 74, whatever the population is, an average of 74, and a standard deviation of 18. So the distribution of the population would look like this here, what I have in red. And so you can see how this is spread out. This is the population distribution. Now, in chapter 8.1, we're looking at a sampling distribution. So if we take samples from the population, what would the sampling distribution look like? What would the average be of all the samples I take? And then what would the standard deviation be of all of the samples that we take from the population? And that's called the sampling distribution. So if we take a sample of size 36 from the population over here, we would get a sampling distribution if we continue to do that over and over. And what we learned is that when we take a sample from the population, the mean of the samples, right, and so it's the x bar, the mean of all the x bars is going to just be equal to the population mean. So in this case, this equals 74. And then the sampling distribution would have a different value. I'm sorry, the standard deviation is not going to be the same as here because this is just the population. When we do samples over and over and over again, they're going to tend to be very close to 74. So we have an adjusted standard deviation, or what we call the standard error, right? And so this is what we call the standard error. And the formula for the standard error, right, is the population standard deviation divided by the square root of n. So in this case, we would have 18 divided by the square root of 36. This case would be 3, because that's 6. 18 divided by 6 is 3. So what we find is that the standard error, or the standard deviation of the sampling distribution, is 3. The mean is always the population mean. So that's where you have 74 right there. And so we'll apply that to this question here, 8.113. Looking at this here, you're given a graph. This graph is the sampling distribution. And so you have these values here, 600, 620, 580. And so what we learn is that since this is a sampling distribution, the standard error is 20, which we have here. The sample size we knew was we're getting that from part C here. And so the standard error is 20, and the mean, right, the mean of the samples is 600, because that's the samples will always be very close to the population mean. And so those are our answers. There's 620 for that. And then if the sample size is 9, what is likely true about the shape of the population? So we can answer that question. So answering this question here, remember there's a relationship between the distribution of the sample means and the population. So if the population is normally distributed, then the distribution of the sample mean would be normally distributed. We also know that the distribution of the samples will also be normal if the sample size is at least 30 or more. But in this case, since we have a small sample size and our distribution is normal here, we should assume that the shape of the population must be normal also. So you could take a look at that explanation here. And so we would have that answer right here. The shape is normal. Since the distribution is normal, the population would be normal, especially because of a small sample size. And then in this case, if the sample size is 9, what is actually the standard deviation of the population? So in this case here, this is where we know it's 20 here. Sample size is 9. And so we have that formula, right? The standard error is equal to the population standard deviation divided by the square root of n. And so in this case, you can see this is the population standard deviation right here. And so to use a little algebra, we get that in order for the sampling distribution to be 20, the population standard deviation must be 60. 60 divided by 3 is 20.